Till now we discussed about different types of frequency modulated waves. Now let's discuss about the generation of different types of frequency modulated waves. We have two different methods for the generation of frequency modulated waves. One is indirect method and the other is direct method. As we have already discussed about the generation of narrowband frequency modulation, in case of indirect method, first we will generate narrowband frequency modulated wave. From there we are going to give it to frequency multiplier where we are going to have a wideband frequency modulated wave. Whereas in case of direct method, we will directly change the carrier frequency is directly given to the input modulating signal to generate frequency deviation delta f, from which the frequency is varied to get the frequency modulated wave. So let us now discuss about the indirect method first. In case of indirect method, this is the block diagram for the generation of wideband frequency modulated wave. When message signal is given to an integrator, and this is crystal control oscillator which gives different types of frequencies which are required for us. So this is similar to the generation part of narrowband frequency modulation. Here frequency multiplier value can be decided by us. It depends on our hardware part. So when narrowband frequency modulated wave is given to frequency multiplier, frequency of narrowband modulated wave gets multiplied and we will get wideband frequency modulated wave. If you need to get more frequency, you can use some more frequency modulated circuits to get wideband frequency modulated wave. Here, as we have already know, S of t is equal to, for wideband frequency modulation, AC into cos of 2 pi fct plus beta sin 2 pi fmt. So from this equation, we can write S of t as S of t is equal to, this is equation for narrowband frequency modulation. So when this is passed to frequency multiplier having a value n, you will get an equation which is nothing but S of t is equal to AC into cos of 2 pi n fct plus n into beta sin 2 pi fmt. So from this equation you can observe that carrier frequency is multiplied n times. Similarly, modulation index is multiplied n times to get wideband frequency modulated wave equation. And here it's important to note that frequency of modulating signal didn't vary. So frequency of carrier and modulation index can be varied by using this frequency multiplier, whereas the value of frequency of modulating wave always remains constant. Now we'll discuss about direct FM. Here this is second method of generation wideband frequency modulation. Here instead of going for narrowband frequency modulation, we'll directly generate this. Here we are going to use a Hartley oscillator. This is called Hartley oscillator. Here this C of t is varicap, which is nothing but variable capacitor, or it can be called as a varactor. Here C0 is a capacitance without modulation. So this delta C varies depending on the voltage which is applied, and the transition capacitance will be inversely proportional to the reverse voltage what we apply. So whatever voltage we apply here, this will be inversely proportional to the voltage, we will get the capacitance values. So from this Hartley oscillator, we can get a frequency of oscillator as 1 by 2 pi square root of L1 plus L2 into C of t. And if you don't go for modulation, you will have F equal to 1 by 2 pi square root of L1 plus L2 into C0. But if you go for modulation, you will have 1 by 2 pi into square root of L1 plus L2 into C of t, where C of t is C0 plus delta C cos 2 pi fmt. So if you substitute these values, you will have final equation for frequency of oscillator as 1 by 2 pi into square root of L1 plus L2 into C0 plus delta C cos 2 pi fmt. This is with modulation. Without modulation, you will have 1 by 2 pi square root of L1 plus L2 into C0. So by solving this, you will have this modulated frequency of Hartley oscillator as f0 by square root of 1 plus delta c by c0 cos of 2 pi fmt. So depending on delta c and c0 values, you will get different frequencies based on this unmodulated frequency or wideband frequency modulation. So finally, by applying all these equations, you will have Fi is equal to f0 plus delta f cos 2 pi fmt. This is obtained only after delta c by 2c0 is equal to minus delta f by f0. This equation is obtained since we know that the variation of capacitance varies depending upon the voltage value. We know that voltage varies depending upon the frequency value since we are considering the frequency modulated wave. So by variation in frequency, you are having variation in voltage. So when voltage varies, capacitance also varies following the relation C is directly proportional to 1 by reverse voltage, as we have already discussed. So finally we are having an equation for instantaneous frequency as Fi equal to f0 plus delta f cos 2 pi fmt. This is the equation for frequency modulated wave. So since this equation is satisfied, we can obtain different frequency modulated waves using this direct wave equation.